Jai Hind everyone. I Neeraj Sharma, Assistant Professor EC Department at Akgec Garg Engineering College, Ghaziabad. I am before you to present the video lecture for the subject Microwave and Radar Engineering, whose code is KEC 074. So in this complex video lecture series, I have just in this lecture I will give the information or present the technical content regarding the microwave tubes. So the topic which I have chosen, that is the microwave tubes, because this microwave tubes is very important from the microwave area, because it is used, microwave tubes are used to generate the microwave signals, so that we can generate the microwave signal with the help of these microwave tubes, and we can also use it as for a some measurement purpose, like either we are measuring VSWR or reflection coefficient and other technical parameter we can also evaluate with the help of this microwave tubes. Also, this is one of the essential component in the microwave testing, when we are going for the perform the experiment with the help of this microwave for microwave using the microwave test bench. So this is the first one component which is going to use in the microwave test bench. So in this already I have discussed this in previous lectures also regarding the two cavity crystron, but in this I will focus, in this lecture I will focus on to the velocity modulation process inside the two cavity crystron amplifier. So in this continuation, so just initially the microwave tubes are used for the generation of microwave signals. So this is categorized into the two classes. The two classes, that is the first one linear beam tubes, second one closed field tubes. Linear beam tubes comes under the category of O type category, and cross field tubes come under the M type tubes. So in this O type, in linear beam tube, the electrons emitted from the electron gun then receives a potential energy from the DC beam voltage and accelerated toward the anode. Okay, first one, electrons comes out from the electron gun with the receives a voltage V0 and accelerate toward the anode side. With the it will move through the gap. So as a result, what happened? The potential energy is now converted into the kinetic energy before they arrives in the interaction region, that means in the drift space when they comes out into the gap. So in this interaction, in the interaction region, these electrons faces the microwave field when we are applying at the input cavity. We will apply it at the input cavity, and either at the input cavity, when the electrons will interact with this microwave signal, so the field, microwave field can be maybe accelerated or deaccelerated depending upon to the phase of the microwave signal. So when if it is accelerated or deaccelerated, it depending upon to the what actual force will be applying at that time. So after that, the acceleration or deacceleration of the electron beam result in the bunching of electrons. That means the velocity will be reduced, and after that what happen? The electrons are get together, combined with each other at a certain interval in the drift space, and they will create the bunch, and this output and arrive at the output structure. After that, at the output structure, these bunched electrons induce a current and give up their kinetic energy to the output magnetic field, and finally they will be collected by the collector. So throughout the journey, the electrons in the electron beam remains together with the help of focusing magnetic field, whose axis coincide with the axis of the electron beam. So in this this is the working working procedure for the microwave microwave linear beam tubes. So this is the classification for the linear beam, that is the O type. It is having either cavity based, which initially I have discussed in the previous slide. So it is having the resonant, and it is classified into the it is having klystron tube, reflex klystron tube. Okay, klystron tube as well as reflex klystron, twistron, as well as when the slow wave structure, this one is cavity, this is slow wave structure, technology will be used here. That means here it is also of two types, the forward wave as well as the, it is break out into the forward wave and the backward wave. So forward wave, that means it will use the principle of traveling used into the TWT, where helix is used as a slow wave structure. So helix, TWT tube, one of the important thing that we important device tube which can be used for the signal generation of microwave signal, and the coupled cavity traveling wave tube. In the backward wave, we are use the backward wave amplifier or the backward wave oscillator. So in this way, the characterization or dividation, the category is further divided into the linear beam O type, that is cavity, and the slow wave structure. And also for M type, as we have discussed this one, M type. So in this M type, mainly the magnetron will be used for the generation of microwave signal. So in this series, how the electron bunching will take place. So as you can see with this Applegate diagram, this Applegate diagram will explain about the bunching of the electron inside into the buncher cavity, into the drift space. So what will happen? Let's say just we are just this is in a simple sine voltage we have applied in between to the gap. So Vs is equals to V1 sine omega t. This is the sine wave we are reaching here, and here we have considered the electrons. This one, this is Ta, this is Tb and Tc. So in this is an early electron which is comes at the first initially emit from the electron gun, and it will move when it will comes to the gap of this gap. As you can see, this one, this buncher cavity and the catcher cavity for the two cavity klystron amplifier, when this early electron will for the negative sign, this one negative sign or the negative region will first come into this gap A. So it will now deaccelerate and its velocity will be retarded or deaccelerated. So its velocity will be reduced. So the velocity, let's say V0 will be enter into the gap, but after interaction with the magnetic field, microwave signal or the field, this will be now retarded. So the speed, its speed will be reduced. So that means it will move with the some less speed with respect to the initial speed V0. After that, this reference electron, reference TB, where we are just move into the where it is neither positive nor positive. So when it will microwave signal interact in this with this signal, so it will be unaffected by the in the gap, it is unaffected with the microwave signal. Now its speed will not, its speeds will be remain same, let's say V0. So it will be the same speed will move. After that, when the next electron will for the positive half cycle will comes out, enter into the anode region. When this entered into the anode region, then in the gap region, so and move towards the anode side. So what will happen in this? So it is a positive sign, and when this enter into the gap, this gap, it will enter into this gap. So what will happen? So after that, this one now enter into this gap, it will be accelerated by the either it is comes later on after this electron, reference electron, this will now accelerated by some speed. So after accelerated the speed, so what will happen? Its speed will increase. So its velocity will get changed. So when the velocity will get changed, so it will speed will increase. So it will become the faster. So after certain interval of time, these three electrons are now bunches at this position, and the bunching will be created, and this bunch will be collected at the output cavity, and the current will be take out from the output cavity end. Okay, so this is the simple working of the bunching process. So what will happening in between in the duration, that in the gap A, all the things are happening in this gap A with these 3 electrons, early, reference or late electron. The what will happen is happening into this duration in this gap A. So their velocity will be get changed. So now here how the velocity modulation will take place, now we will see in this lecture. So here I have write it here that the velocity modulation process for 2 cavity klystron amplifier. Here this is cathode and the configuration is applied signal V naught we have applied here. So what will happen, this is buncher cavity, this is the drift space. So the signal will enter here with velocity V1, V naught, this one V naught, and it will be comes out the VT1 when it comes out from the this gap. So the velocity will take, modulation will take place here. So that because of this velocity increase or decrease, the electrons will be are now bunched here, and bunching will take place either in this period. So let's say here the distance 0 to D, this will be the at T naught position is 0, at T1 it is distance D, and T2 and T3 in the another gap. So how it will at the collector end, it will be collected here, and from this catcher cavity we will get the output, RF output we can take here. So in this, how this velocity modulation take place, so we can now discuss here. So when the electron first accelerated by high DC voltage V naught, high DC voltage V naught. So the velocity at this point, so by voltage before entering this buncher cavity means enter into this space. So the velocity V is uniform and it is given by V naught is equals to under root of 2 into E into V naught over M, or it will be 0.59 into 10 raised to power 6 under root of V naught meter per second. So after this, now this velocity it is enter into this gap, this one it is now entered here. So what will happen after that, now at the when a microwave signal is applied to the input terminal, so means from this end the microwave signal is now applying here. So what will happen, applying at the input terminal, the gap voltage between the buncher grid will be appear. In this gap the voltage, let's say it will be denoted by Vs, buncher gap voltage will be appeared here. So the gap voltage, so the gap voltage between the buncher grid V of S, it is given by, let's say Vs is equals to V1 of sin omega t. Vs is equals to V1 sin omega t. So this is the V1 is the amplitude of the signal, and V1 is much less than V naught, and also V1 is much less than V naught we will consider here. So now the average transit time through the buncher gap with distance d, this means electron will move from this position to this position. So the transit time, average transit time for this gap will be given by tau is equals to d upon V naught. Okay, or we can also write it T1 minus of T naught. Okay, so the average, this is the transit time. So the average gap transit angle. Now after that the average gap transit angle can be expressed as theta g is equals to omega into tau or omega T1 minus T naught, or we can also write it like this, omega into d by v naught, omega d by v naught. Okay. So what will happen in this? After that, so the average microwave voltage what will be the value of this voltage in this? So average is given by Vs 1 upon tau integral from T naught to T1 of this voltage, V1 of sin omega t into sin omega t into dt. So now we can solve this value, this value when we can evaluate. So it will become Vs equals to V1 upon omega into tau cos of omega t naught minus of cos of omega t naught plus omega d by v naught. So now we can arrange it into some another form. So let, for that point of view, for the arrangement, just we are considering, let omega t naught plus omega d into omega d by 2 v naught is equals to, let us say, omega t naught plus theta g by 2 is equals to a, and we can consider here omega d by 2 v naught is equals to theta g by 2 is equals to, let us say, b. So when we can arrange this equation into constant a or b, so this equation will comes as a cos a minus b minus of cos a plus b. So as per the trigonometry, as per the trigonometry, cos a minus b minus of cos a plus b is equals to 2 sin a into sin b, cos sin a into sin b. So when we will apply, so this equation will become Vs is equals to V1 sin omega into d by 2 v naught upon omega d by 2 v naught into sin omega t naught plus omega d by 2 v naught, or in terms of theta g, or we can also write it Vs is equals to V1 sin theta g by 2 divided by theta g by 2 into sin omega t naught plus theta g by 2. So, this voltage will be comes out in this form. Let here we will define beta I, let us say beta I is equals to sin omega d by 2 V naught by omega d by 2 V naught or sin theta g by 2 divided by theta g by 2. This is the beam coupling coefficient. That is the beam coupling coefficient of the input cavity. Beam coupling coefficient of the input cavity. So, this voltage we can now, this value we can calculate with the help of this process. So, where we have beta I we get beam coupling coefficient. So, now after immediately after the velocity modulation, that means the velocity will be get changed. So, immediately after modulation velocity, the exit voltage, that means the velocity modulation will take place in this gap A. So, the velocity will get changed when electrons comes out from this gap A. So, this value will be Vt1. So, the velocity modulation, so the exit velocity the exit velocity from the buncher gap given by what will be V naught, what is initially, it is V naught is equals to under root of 2 into E into V naught upon M. So, when will be comes out, so this will be increased by this another velocity what we get previously, it will be now added on. So, the Vt1 is equals to under root of 2 E upon M into V naught, just a minute, V naught plus beta I V1 sin omega t naught plus theta g by 2. This one what we gain, this one beta I into sin omega t naught plus theta g, this will be the value, this will be added on now. So, or we can arrange it into 1 plus so, when we will compare this value of voltage, velocity which is comes after the gap A from the buncher gap. So, the velocity will now represented in this form, and when we will compare this with the this equation, with the equation of amplitude modulation. So, where we can modulation equation we will write like that, AC into 1 plus AM cos omega mt into AC into 1 plus beta into cos omega mt into cos omega ct. So, when we will compare this equation from the amplitude modulation equation, so we will find that this one part, this part is where the beta is the modulation index or the modulation depth for the signal. So, in the same way, when we will compare that equation with from that equation for the amplitude modulation, so this will be the, so the factor, so the factor beta I into V1 by V naught is called the depth of velocity modulation. Velocity modulation. So, when beta I into V1 is much less than V naught, so we can write it, this equation we can now write it like Vt1 is equals to V naught into 1 plus beta I V1 beta I V1 upon 2 V naught into this sine omega t naught plus theta g by 2. So, this will be the equation for the velocity modulation of electrons in the after the Buncher cavity. So, this in this way we can equation for the velocity modulation. This will be the equation for velocity modulation. So, in this way we can explain the velocity modulation process in for the two cavity klystron amplifier in the Buncher gap or Buncher cavity. So, this is now from my side regarding the microwave tubes and the bunching process for the velocity modulation in the Buncher cavity for two cavity klystron amplifier. Thank you and Jai Hind.